This video contains the solutions to take-home problems number 20. For this first one, we have to solve the inequality 5x minus 3 is less than 17. And the basic idea behind solving inequalities is that we want to treat them essentially like equations, doing opposite operations to both sides until we get the x by itself. So in this case, when we have 5x minus 3 is less than 17, we want to get rid of the minus 3 by adding 3 to both sides. That's going to give us 5x is less than 20. And then we want to get rid of the 5 by dividing both sides by 5. And that gives us the inequality x is less than 4. Now for all of these problems, we were asked to put the solution into interval notation. So when we have x is less than 4, we write that in interval notation as the interval from negative infinity to 4. And remember, when we use interval notation, whenever we have an infinity or a negative infinity, we always use round parentheses. In this case, since it's a strict less than, rather than a less than or equal to, we use round parentheses around the 4 as well. This time we have 4 minus x is greater than or equal to 8. So again, if we want to get x by itself, one thing we might do is subtract 4 from both sides. That's going to give us negative x is greater than or equal to 4. And now if we want to get rid of the minus sign in front of the x, we could multiply both sides by negative 1. That would get rid of the negative sign. But it would also change the less than or equal to, the greater than or equal to a less than or equal to. It reverses the direction of the inequality. So that would give us x is less than or equal to negative 4. So whenever you multiply or divide an inequality by a negative on both sides, that reverses the direction of the inequality. And again, writing this in interval notation, this is the interval from negative infinity to negative 4. This time, since it's a less than or equal to, we use square brackets. All right, now we have x's on both sides, so there's a few different ways that we could approach this, but usually we want to end up with an inequality that has an x on the left. So I'll start by subtracting 6x from both sides. And then we'll also subtract 1 from both sides. That's going to give us negative 3x is less than or equal to 6. Divide both sides by negative 3, that's going to give us x is greater than or equal to negative 2. Again, when we divide by a negative, we reverse the direction of the inequality. Writing that in interval notation will be the interval from negative 2 up to infinity. Again, it's a greater than or equal to, so we use square brackets around the negative 2. Now we have a compound inequality, and again here the idea is that we want to treat this like an equation, although we're really treating it like an equation, like two equations at once. So if we imagine that we had the inequality 4 is less than 2x minus 10, the way that we would start to get x by itself is we would add 10 to both sides. But then if we think of this other inequality, 2x minus 10 is less than 20, we would also want to add 10 to both sides of that inequality. So the idea is that we're sort of adding 10 to all three pieces of this compound inequality. That's going to give us 14 is less than or equal to 2x, which is less than 30. And now we want to get rid of the 2, so we'll divide everything by 2. That gives us 7 is less than or equal to x, which is less than 15. And again, writing that in interval notation, since we have less than or equal to by the 7, we have square brackets, and since it's a less than by the 15, we use round brackets. Last one, again we have a compound inequality, and again we're going to do our operations to all three pieces of this inequality. So to get x by itself, we'll start by subtracting 4. That gives us negative 7 is less than negative 2x, which is less than 5. Then we'll divide everything by negative 2. What's that going to give us? Well, in the middle it's going to give us x. When we divide by 5 by negative 2, we get negative 5 halves. And when we divide negative 7 by negative 2, that gives us positive 7 halves. But just like always with inequalities, when we divide by a negative, we have to reverse the directions of the inequality signs. Now normally our compound inequalities are always written with less than or equal to signs, and now we have one written with greater than signs. So this is just going to seem backwards to us. So what we'd like to do is flip this around. So when we flip it around, x is still going to be in the middle, negative 5 halves is on the left, 7 halves is on the right, and now again our greater thans become less thans. And this is a little bit easier for us to interpret. It makes sense because if we think about a number line, on the number line, negative 5 halves is to the left of 7 halves. So having our compound inequality written in that same order seems more natural. Writing this as an interval notation, since they're both strict less thans, we use parentheses for each side, negative 5 halves to 7 halves. And that's our final answer.